Alright, this is going to be a review of exit slip 17 from last class. So exit slip 17 was covering the topic of integration by substitution, or as we're probably more familiar with it by now, U substitution. So as we look at these two problems, we're basically going to be trying to identify a good choice for U, based off of that choice determining a du, and then hoping that our integral becomes simpler as a result of that substitution. So with this first problem, there's not too many options for u, so likely you all already chose 3x plus 1. So I'm going to go ahead and make that choice off on the side here. So let's go ahead and let u be 3x plus 1. It's the quantity that's being raised to a power. If we weren't going to use u substitution, of course, we would have to multiply 3x plus 1 out 3 times, which sounds like more work than we'd like to do. So just keep that in mind. That's why we're doing u substitution. Now, based off of our choice for u, not even looking back at the original integral, we know that the derivative of 3x plus 1 taken with respect to x would be simply 3 dx. And now's a good time to go back and compare to the original integral. Notice we've got a little dx term hanging out, but we don't have that extra factor of 3 that we just found when we took the derivative of our definition of u. So to make it match perfectly, we'll simply divide both sides by 3, so that 1/3 du will be able to take the place of dx. If we rewrite the original integral now, fully in terms of u and du, we will have 1/3, actually you know what, I'm going to be really literal for my first, right? So let's try that again. Let's go ahead and write this as the integral of u now, instead of 3x plus 1, raised to the power of 3, and in place of dx we'll put in 1/3 du. So again, I'm trying to be just really literal with that substitution at first glance here. And then the hope is that this has created a simpler problem. So sometimes what we often do is pull the constant out front of the integral. So I'm going to go ahead and pull that 1/3 out now. And then of course we're used to the integral symbol, and then the quantity that we're integrating, and then the d variable being the bookends of the integral. So as we've talked about in class, notationally you'll never see the integral symbol without a d variable at the end, because that piece at the end is telling us what to integrate with respect to. So just to clarify that, I know it's a little new at first. So if we go ahead and actually compute this integral, it looks like the power rule is all that we'll need now, which is good. The power rule is a very useful tool for integration. So integrating u to the 1/3, we get back u to the 4th over 4. This is an indefinite integral, so I'll tag on a plus c as our constant of integration. And although we feel rather accomplished at this point, we've done some integration, we need to end by back substituting in for u. So to wrap up this first problem, let's go ahead and pull out the fractions as a 1/12. And then in place of u, I'm going to go ahead and substitute in 3x plus 1. That term was being raised to the power of 4, and then we'll say plus that constant of integration. So this here could be the final answer for the original integral. I wrote 1/12. You may have just as easily have written divided by 12. So hopefully that one looks pretty good so far. We'll look at the second problem, which throws us a little bit of trigonometry. So the integral of sine cosine is a great example because you can't really go wrong with your choice of u. Looking at this problem, of course, we know that the derivative of sine is cosine. We know that the derivative of cosine is negative sine. So I don't have a negative floating around, so I think I'm going to go with that first choice we just discussed, which was if we choose u to be sine, let's go ahead and do that, then the derivative of sine taken with respect to x would be just cosine of x. And this works out really well because that's exactly what we've got left over. So not all u subs work out quite this nicely, but when they do, we'll take them. So rewriting this integral fully in terms of u, we now have the integral of u du. As we've said, this is about as good as it gets with regards to u subbing. So our power rule will give us the integral of u as u squared over 2. We're again working with an indefinite integral, so don't forget that plus c for the constant of integration. And back substituting, when we see u, we can simply insert sine of x. So we have sine of x quantity squared divided by 2 plus c. Of course, just small notational differences. You may have written this as 1/2 sine squared of x, if that looks any better to you, plus c. So either format in terms of our answer would be just fine. And that's it. So hopefully you're feeling pretty comfortable with u substitution. In the homework, we've definitely seen some harder problems, but this is the main idea. All right, time for some new stuff.